Okay, so today we'll have one top hat question at the beginning of class, and then we'll have a set at the end. Okay, so let me remind you again about the ECA tutor room. That's across from the bookstore, right across the street, up on the second floor. So we're doing our very best to train these people in the curriculum. It's not perfect though, but it's the best thing on campus you're going to find for help with this curriculum because we're training them specifically in it. Okay, so if you have a bad experience, try a different time. There's like more than a dozen different people working different shifts. Go there a different time, find someone that you like, and then also you can just go there and just work on your homework. And then whenever you have a question comes up, then there'll be someone there to help you. Okay, so take advantage of that. I've posted on Blackboard announcements the hours of it, which is 5 days a week, okay? Our first exam is coming up next Thursday, so I have several things to help you prepare. In the exam preparation area on Blackboard, there's 2 documents, a review outline, and sample test items. I'll show you those in a second. And then there's a place, an online problem, kind of online homework system called WebWork, where you can go and work for some extra credit on the test. So depending on how many you get right, you add a little bonus to your exam, and that's a good way to help study a little bit. And then I'll have all the top hat questions we've had so far in like review mode, okay? So let's go show you some of these things. So first of all on Blackboard, so if you go to the exam prep area over here on the left, you'll see this, hit exam 1. Here's the outline I told you about. This is comprehensive. There's nothing on the exam that's not somewhere in this outline. The sample items is not comprehensive. There may be 10 or 12. All it is just to give you a feel for what the test is like. Okay? So this is not a whole sample test. Okay? So this is just to give you a feel of maybe what the exam will feel like. And all of those questions pertain to content that we've been doing. So it's good practice and a good way just to get a feel for the exam. Okay? And then WebWork. So I put on here WebWork, and then just reminded you about the top hat problems. So with WebWork, we'll go there in a second. So let's go there now. So if you go to this website, and if you've got internet, go ahead and do that. So if you go to WebWork, this is what it looks like. webwork.asu.edu. 170 is the first column, and I'm the first instructor there, so just hit Ashbrook. You might have to log in with your ASU Right ID, just like logging into my ASU. And then most of you will see something like this. That means you're in, okay? If you don't see this, or it's saying login not recognized or something like that, then you need to email me. I've put it on Blackboard here. You need to email me your ASU Right and your posting ID, and I'll get you enrolled in the system. It's because if you join late, you might not be in the WebWork system. So you need to send me your ASU Right ID and your posting ID, and I'll get you enrolled. Okay? So you'll see here, it's now open, Exam 1 review problems. There are 32 practice problems. This also is not comprehensive. So this is also not like a sample test. This is just the best problems I could find that relate to the stuff we did from this system, which is different, okay? So it's just, but the nice thing about this is you get immediate feedback. If you put an answer in and it's not right, then you know right away. Or if it's correct, it'll tell you it's correct. And so that's an advantage to working problems out of the book, because you get that immediate feedback, which is helpful. Okay. Notice that for bonus, you only get limited attempts. So on like open-ended questions, you got 5 attempts. On things like true and false and matching, you just get 2 attempts, right? So don't put true twice, okay? All right. So, but just be aware if you're going for bonus, it's not just unlimited attempts. Keep track of on a given problem. There's a different number of attempts possible if you're going for bonus. So then, for bonus, the submissions are due Wednesday night at midnight, the night before exam. Okay. After that, the system's still totally available. You can work the problems. It's just that all the answers are available, and you can't earn any more points. But you can still work problems and then also see the answers. Yeah.
And so failed attempts or anything do not count.
That's right. If you get number 18 right on the 5th attempt, you get full credit. Full credit for that. Okay, so that's Blackboard. That's web work. And so again, the instructions for web work are posted in the Exam 1 folder on Blackboard. So all that information's there. And so these are some things to help you study, especially the material. Of course, all the worksheets, readings from the workbook is critical, right? That's because everything we've done so far. So this is just some extra resources, basically. You want to focus on the homework and the worksheets that I've assigned, because that's the type of questioning that you'll have on the exam that you're responsible for. Questions on, so that's Thursday, and so you have a written homework due Wednesday, normally, just normal. All that stuff is on the exam, and then you have the web work to work on. So there won't be a reading assignment for Monday. Okay, so you've got plenty to do to get ready for the exam. So we just won't have any reading or workbook for Monday.
Is there still a homework due Wednesday?
Yes. Okay. Other questions? All right, so I think we talked about that. So yeah, use that. Go to that tutor room, use it. Okay. We talked about the exam, so we'll keep talking about it next week. It's next Thursday, and you'll take it just like you took the pre-test. You'll go in on your own time with your Sun card. You can have a calculator now, and you can have all the time you want. You have to be in the door by 6:30, and then it closes at 8:15. They take the last test at 8:15. Yes, ma'am.
Why is the test not on the day of class?
Why is it not? Because we picked it for Thursdays. Are you saying why don't we take them in class? Is that what you're saying?
Well, no, like it doesn't make sense if we have class Monday, Wednesday, Friday, which is on Thursday. What if we have class on Thursday? Works. That's why.
Yeah, if you have a whole day of scheduled things on Thursday, then just talk to me. Yeah. Yeah, there's some people that don't come on campus. They work all day Thursday. We make other arrangements. Yeah. Other questions? Okay, let's do top hat. Okay. So one question about your reading. So just a minute or two. What's the idea behind the term composition of functions? So you can't have the book open, obviously, on your laptop, just pathways. And no talking. Last chance. Transfer in. Hurry, 20 seconds. Okay, last chance. I'm going to close it up. Time is up. Okay, so if you did the reading, this should be pretty easy. What's the idea behind the term composition of functions? Outputs of one are the inputs of the next. So it's two functions like in succession. The output of one function becomes the input of the next. So in the first class, we were at 50%. You guys were a little bit better. Do your reading, okay? Make sure you do your readings. Okay, dokie, let's see here. So what I want you to do is open up to page page 102. On page 102 in your book, they have these two tables, function f and a function g. So the function f, what's its function? What does it do? It takes, for input, it takes the average length of workers' shifts, okay, in hours. So what lengths of shift do they work per day? 9-hour shifts, 12-hour shifts? And then it outputs then how many accidents you would expect in a year. So when workers have longer shifts, there's tendencies to get tired, make mistakes, and more tendency for more accidents. So the longer the shifts are, the more accidents they're seeing over a long period of time. Okay, that's the function f. Inputs the length of shift, outputs the number of accidents per year. G is a function of the number of workers employed each day. That's the input. And its function then is to give the average length of the shift for the given number of employed workers. So the more workers you can employ, the shorter you can make their shifts. Okay? And that's what's happening here. More workers, shorter shifts. So that's the f function and the g function. So back on page 100 is a blank sheet. Turn back one page is blank. Back one page. So you can either write on that blank sheet or you can write in your own notebook, and these are the questions I want you to answer, okay, based on that table of those two functions. Okay? So you're right out of the starting gate. Don't spin your wheels. We got lots to do today. So you're answering these questions relative to those two functions. And then I'm going to continue the workbook check from last time. What's the average length of shifts when 70 people are employed? Which function do you look at, F or G? And is that 70 the input or output of G? So we're doing G of 70, is that right? Is G's function to take a number of people that are employed? And then its function is to give you average length of the shift, which is? So this is expressing that in function notation. So when we talked about function notation, we said that over here, like on the right, was like the rule, right? But it could also just be the value of the output. what you get when you cranked out the rule. So it can be either. It can be just the output value, the final answer, or it can be, in general, whatever the rule is that gives you the output. Is that okay? Does that make sense? Okay. So, but the key is that whenever you see function notation, as a whole, that thing is representing what? Input or output? Output. G of something, F of something, that's representing output. In this case, the output of G when the input is 70. Okay, so average length of the shift in a year with 7 accidents. So we're going to look at function F or G. And 7 accidents, is that the input or the output into F?
The output.
The function of F is to give a number of accidents per year. So won't it be like that? Is that right? So we're asking a question, what input into F would give an output of 7? And that is the 9-hour shifts. 9-hour shifts result in about 7 accidents a year.
Do we have expressed that like in inverse, so like the inverse?
Yeah, we're doing that Monday. But yeah, that works. Yeah, we're working on that Monday. Okay. All right. And then I think this is also the F function, F of 11. Is that right? Is that right for number 3? Okay, so number 4, we've got 65 workers. We want to know how many accidents we would expect. So if we got 65 workers, what function are we going to look at? We're going to look at G. But does G give us the number of accidents? No, but we can get the length of the shift. And from that, so this average length of the shift, is it an input or is it an output? In G, it's what? It's output. But now in F, input. This is the idea of composition of functions, a process where you take the output of one and it becomes the input of the next. Okay? And given the F function, given an average length of 12, we get 13 accidents. Same thing with 100. 100. Is it the input or the output of F or G? What is it? She wants input of G. Agree? 8. Input or output of F or G? First of all, it's the output of G. And that becomes the input of F. So that we can get the expect 6 accidents. So, does it make sense? Oh yeah, so that's what we're going to do next. You read my mind. Everyone get the process. This is composition. Using 2 functions in succession. Taking the output of one becomes the input of the next. So, she read my mind. We want to represent that with function notation. So again, what was the 65? How many? X 13. And then, look, we're going to use more workers, so what do we expect about the accidents? Go down over time, right? And it's 6. Makes sense. Using more workers, we expect less accidents. Okay? So, how can we express that number 13 in function notation only using the number 65? So, I'm going to pose her question back to you. See if you can do it. So, only using the number 65, express in function notation how you would get this 13 accidents. See if you can do it. So what would you write? Just everyone for this, work on it yourself. What could you write using the functions f and g to express this number of accidents given 65 workers? And same thing with this. With 6. So what came first? We did what with the 65? Plugged it into G. G of 65 represents the output of G. Okay, and what are we doing with the output of G? Inputting it into F. So we can just, that's going to be our input into F. And how do we write that? F of that. Okay, and so the notation for that, another notation, is to write with a little circle like this. So when you go from left to right, it goes F, then G, F, then G. But what process comes first? G comes first. G, so whenever you see this notation, you read it F composed with G, F composed with G, but what it represents is doing the G process first, putting that output into F. Okay? This would be, 6 would be F of G of 100. G of 100, is it output or input? G of 100, is it output or input? Is it input? The G of 100. So this right there, that I'm putting a red box around, is it an output or is it an input?
It's both.
It's both. It's the output of
G.
G and the input of F. The input of F. It's both, right?
So you would find G once you have that, so you can put it into the function of F.
That's right. Just like when you found the 13 and the 6. That's right. That says put 100 into G, take that output, and put that into F. That's right. So now I want you to do on number 4, next to those tables, up on the next page, on page 103, parts A, B, and C. Parts A, B, and C. So page 103, number 4, A, B, and C. F of G of 80. Does it have real world meaning? Does it work? And what does it represent? So in general, that whole thing, F of G of 80, looking at it as one unit, is it an output or an input, and is it for F or G? So is that an output or an input of F or G? That's an output of F. That's what that is. That's an output of F when its input is the output of G. When its input is 80. Okay? That's an important skill to be able to look at that and say that that's the output of F when its input is the output of G when its input is 80. Okay? So that whole thing is the output of F. So it's going to be a number of expected accidents when 80 workers are employed, which is it 8? 8. That's per day. So just practicing that same thing. G of F of, what's that? G of F of what? So ignoring the context, just practicing. Is that an output or an input of G or F? That's the output of G. Which output of G is it? When? When the input is the output of F. When its input is 9. So that's the output of G. If you had an input into G of the output of F when its input is 9. You see? Okay. What is the output of F? What is that? 7 accidents per year. Right? And so what's the function of G? G takes the number of workers and gives you an average length of shift. So what are we trying to do to G here? We're trying to give it a number of accidents, but the function of G is to take the number of workers. So what does G do with this? Yeah, it doesn't like it, right? It ain't happy. It won't give anything, right? So G says, no, I don't want number of accidents. My function is to take the number of workers employed each day. That's all I do. I take the number of workers, and I give an average length of shift. I don't know anything about accidents. So it just rejects 7 accidents. It just rejects that. Does it make sense? Okay, finally, what was it? F of G of 13?
F of G of X.
Yeah, F of G of X. So that number 13, tell me, is that that 13, is it an input or an output of F or G? It's the output of F, so what kind of quantity is it? Number of accidents. That's a number of accidents per year. And so we could figure out the corresponding input of F for number of accidents per year, which is 12-hour shifts. 12-hour shifts. But that's also, if that's G of X, the input of F, then it's also the output of G. Is the output of G hour shifts? Sure it is.
12-hour shifts.
Yeah. So the output is hours of shift, so we're okay. G is how long shifts are, so we want the corresponding number of workers that would give a 12-hour shift. Is that 65?
Yes.
So what do you want X to be, the number of shifts or the number of workers or is it both?
No, so the only thing it is the input into G. If you're writing G of X, it can only possibly mean whatever the input into G is. So what is the input into G? What quantity? Number of workers. Does that make sense? And so X is our 65. Okay, so now I'm kind of, we have no way we have enough time to do all that they have in there about composition. So in lieu of that, here I've got some instructions. Just go do exactly the instructions that I've got here. So first, on page 97, read the intro to number 3. No, so we'll just do all this together, okay? So let's go to. We don't have time to have you work on it and then regroup. So we'll do it all together. So on 97 it says a pebble is thrown into a lake, and the radius of the ripple travels outward at 0.7 meters per second. Your goal is to determine the area of a ripple for a number of seconds since the pebble hit the water. Okay, so flip on over to pair E. Next page, pair E. It says F, we want a function F that defines the radius as a function of time. What's the name of that function, then? What's the name? F defines radius R and it's a function of time. What's the name?
F of T equals R.
Just the name. F. What's going to be our input into this function we're going to name F? Time. And the output's going to be? Radius. So now we need the rule. The pebble, the radius is growing at 0.7 meters per second. So every second, the radius grows 0.7 meters. So what rule, given the time, will give us the radius? Yeah, so every second, it grows by 0.7. So in 2 seconds, it will grow by 2.7s. In 10 seconds, 10.7s, right? That's proportionality. That's our constant multiple, 0.7. We have a second function. Its name is G. What's the input into G? It says we want G that defines area as a function of radius. So the input is radius. And what's the output of that going to be? Area. So what rule that works on R gives us area? What rule that works on R gives us area? Of a circle. That's circumference. Pi, is that familiar? Pi r squared. That's the rule for an input of radius that'll spit out area. So now just think for a moment. Which context would make sense? F of g of, say, an arbitrary x, or g of f? Would one work? Would both work? Would neither work? Would one of those make sense? Would both of them make sense, or would neither of them make sense? Some people are saying g of f of x. Does it make sense? Because the output of f is what? Radius. That has to match the input of g, does it? Yep, that's the input of g, radius. So this one doesn't work because you're trying to put what? You're trying to put area into a function that takes time, right? So f wants time. And it's going to tell you the radius. But now we're trying to put area. That doesn't work. Okay, so we got our two rules, 0.7t and pi r squared. It's actually in the right place. Amazing. So here's the idea. You said we could do which one first? F first? And then G. So this is the idea. Time can go into F, and F spits out radius. Radius can go into G, and it spit out area. So again, is that F of G or G of F? Is that F of G or G of F? G of F, because that means F comes first. Okay, so really everything we've talked about with composition so far has talked about it as a two-step process. You do the first process, take the output, start the next process. But it would be a lot more efficient if we had what? Could we build one function that did it all, right? So if we had one function that just did it all in one step, what would the input of that function be? We just had one function that did the same thing as these two in succession. What would the input of that one function be? And what would the output be?
Area.
Right, so can we build a function whose input is time and whose output is area? That would be like the one-step version of the composition. Okay? So how can we do that? We can do that by, what is f of t? It's 0.7t, right? So we could take g of 0.7t. So make the input of g 0.7t, and remember what g of r says to do. The instructions for g says square the input and multiply by pi. So what's my input? I'm going to square the input and multiply by pi. So this is what we can call h of t, is a new single function whose input is time and whose output is area. Ready? Here it comes. Input time, output area, and here's the rule. So it eliminates the middleman. It eliminates the middleman. You can do it all in one step. Both are considered composition of functions. So the two-step process? No. Oh no. Yeah. Oops. The two-step process that we saw before, that's composition. The one-step resulting process that does it all without the middleman anymore, the middleman was what? Radius? So radius has kind of disappeared. We just got time, output, area. That's also composition. So it's